Hey everyone. For my final project, I decided to create a mini version of a theremin. For those of you who do not know, a theremin is a musical instrument that is played without physical touch. The instrument has sensors that identify the distance of the player's hands from certain parts of the instrument as a way to control pitch and volume. You might recognize the sound being used in horror movies, and it's used as the stereotypical sound for aliens. It almost looks like it's magic. There are a few different videos and instructions online on how to create this instrument, but I decided to go with the directions on the Raspberry Pi project website because of my beginner skill level with coding. This version of a theremin utilizes an ultrasonic distance sensor to detect hand distance and a tonal buzzer to produce a computerized sound. So I did use everything that was listed on the Raspberry Pi website here. The materials I ordered, I did end up ordering everything here. However, I actually didn't need everything. So it did say I needed a solderless breadboard, uh, and it also said I was going to use Sonic Pi. But if you look through the actual instructions, there's no mention of the breadboard, and there's no mention of Sonic Pi. Now, Sonic Pi and the breadboard were talked about during those advanced videos and things that I saw, but this version doesn't use it. Sonic Pi is kind of similar to Python, where you can code things, but it has access to musical instruments. It's a MIDI, which stands for Musical Instrument Digital Interface. So if I wanted to make, I could connect the code to Python and my theremin. I could have made it sound like a clarinet, a trumpet, things like that. But it was just a little too advanced for me to make those things work. So I decided to go with this version just because I didn't need to do all that. So, uh, however, looking through these directions and seeing that there was going to be Sonic Pi and the breadboard, it was confusing at first because it felt like the directions were incomplete. Um, so I was very cautious as I was going through these directions, but I went through it, starting with the distance sensor. So the distance sensor, if the device works perfectly, it sends out pulses of ultrasonic sound and then measures the time it takes for those sounds to bounce off nearby objects and be reflected back. So if my hand was right above it, they would send a signal out, it would bounce back to the device, and then we would measure how much distance there is, and it does it in meters. So with this device in particular, it can measure about pretty accurately up to about 1 meter. So nothing too crazy, but meters still kind of far. Uh, so the first step was to actually connect this device to my Raspberry Pi using four female to female jumper leads. So to make sure I didn't mess anything up, I did use the diagram here when connecting things. I counted out all the pins, making sure that I was connecting everything so that it matched the diagram. I didn't want to mess anything up. So I connected that first red wire you see in the diagram here. That's for power. I put that in the first pin slot on the left or bottom row, depending on which direction your Raspberry Pi is, really. But uh, that's for like the 3.3 volt pin. Then I put the yellow that's indicated here into the GPIO 17 pin, the green, the echo pin to the GPIO 27, and the ground pin to the ground on the Raspberry Pi. This yellow one was for the trigger, which I forgot to mention. But once everything was connected, I did use the code that was provided here on how to detect distance. And if everything is plugged in correctly, I should be able to see a number when I run the program to indicate the distance uh, for the distance sensor that's sensing in meters up to 1. And those numbers would be popping up and moving around as I move my hand above it. Now, when I did this for the first time, nothing actually worked. I got a warning message and things just, there were no numbers coming up. So I did wait till the end of the last Zoom meeting to get some extra help, and we did a little bit of troubleshooting. We did find out that the diagram provided was wrong. The equipment portrayed in the diagram for the sensor is actually a 3.3 volt sensor, but uh, the link that it's sent to, even though it's like the what was it, the British link, um, when you buy the American version of it, you get a 5 volt pin, a 5 volt sensor. So that wire over here, this one actually needs to be connected to this uh, top one right here. So the 5 volt pin there. So once we made that change, we tried the code again, but there was still something wrong. And if you look right here, uh, when it talks about the echo pin and the trigger pin, they wrote it correctly, but in the diagram they switched the wires. So this yellow one should be where the green one is, and the green one should be where the yellow one is. And once I made that change on my Raspberry Pi, we were able to get the actual numbers in the code to work. So this is what the code looks like on Python, having everything here. And when I run it, run module, you can see a number pop up. So the closer my hand is, the smaller the number is. As I move my hand back, that number is increasing up to a meter. And if I completely remove my hand away, it's measuring up to my ceiling and it gets a meter, or as far as it can go. So my hand goes in the way, the numbers are going to change, and that creates the different measurements there. So I'm just going to end this for right now and then throw back. Here we go. So that's what I did then, and we got that running. So the next step was to get and add the buzzer. So luckily, the diagram for the buzzer was all good. It was just me knowing which side was positive, which side was negative, and we got the red to be the positive one over here, and then the black to be the ground, and everything was good when connecting it. Uh, then putting in the actual code for the buzzer, we have this connecting to the Pi here. The distance sensor measuring where the trigger and the echo is, all that from the last bit of code. Uh, but now we just add the tonal buzzer here. So in theory, when everything is added, uh, later on when we start adding the MIDI notes, that's the actual sound for the buzzer to make, it'll make that sound. So we did want to test things out to make sure that the buzzer was connected properly. So after putting in this code here and running it, we actually got an error message. So that error message was because of sensor.distance. For some reason, when they wrote the directions, they changed uds.distance to sensor.distance, which messed everything up because sensor.distance wasn't identified. So it has to be UDS distance has to be that. So another mistake in the directions here, which was another challenge to figure out. But once those things were figured out, everything was pretty much smooth sailing. So uh, I then added all the stuff for the MIDI notes. So uh, so right here, depth distance to tone distance value. This assigned the tone, the minimum tone to the maximum tone, the tone range, adding the note values. So now, depending on my hand distance to the sensor, the buzzer is going to play a note. So as you can see from the full-on code for this theremin, when I hit run, you hear the beep. That's with nothing on it. I get my hand closer, and then I move it around. And you can hear it from there. Now, I did play around with it a little bit more, and just to see, like, I want to be able to see what the values actually are. So if I go in into the code and still put in print uds.distance, I can have the numbers going while the theremin's playing. So if I hit run, I'm going to see my numbers. And now it's going a little bit too fast for everything, so it's kind of hard to read and figure out the exact notes, because as the musician as I am, I want to figure out like which number plays which note, or at least get something close to it. So the sleep that's provided here, the sleep is the speed in which it's reading everything. So if I just change 0.01, which is the fastest speed, which is why those numbers were going kind of crazy, if I change this to 1, it's going to read things a lot slower, so I can actually practice and figure out what notes are what. So if I'm going to run this now, everything changes a lot more slowly. I have my hand up, the numbers are coming through, and the closer the numbers are to 1 meter, the higher the pitch is. The closer I bring my hand to the sensor, the lower my pitch. All right. So that's what it all sounds like. I'm going to add a little clip so that way you can see me actually moving my hand and what it looks like connected to my Raspberry Pi. But basically, that's my whole project. I had a really fun time doing this. I learned a lot about putting in the codes and making sure, and a lot about troubleshooting and making sure all these wires were connected correctly. But it was definitely a lot of fun putting this together. And in the future, I definitely want to try some of the advanced versions I saw online, especially with the breadboard. Now that I did order it, I do want to try connecting and putting in the different MIDI sounds through Sonic Pi, so that way I can start making it sound more like an actual theremin and less like a an old-fashioned computer with some angry beeps. But overall, this was a great experience. So thank you, and I hope you enjoyed. Bye. All right, so here is what my Theremin looks like connected to the Raspberry Pi. I know it's a little bit messy, but here is the distance sensor. This is what measures the distance between my hand and the sensor to generate the number that where the notes are played through the buzzer. So the buzzer is going to sound very computerized like you heard in the video, but you get to see what everything sounds like, and this is what everything looks like when it's connected to the inside. So I'm going to run the program and you can see how it works with my hands moving around. So here it is. Here's the buzz. I'm going to move this over a little bit so it doesn't read my phone. And so when I put my hand over it, lower the pitch. When I move it away, higher and higher and higher. And I can control it without touching. And then it gets angry when there's nothing there. So that is my theremin. I hope you enjoyed listening to the little bit of, let's say, music that I created. So I'll be playing around with this, so learning the notes and having a lot of fun. So thanks.